Alright, in this video I'm going to do an example of how to use law of sines to solve for missing sides or missing angles on a triangle that's not a right triangle when we can't use some of our trigonometric functions. So let's take a look at this triangle. As a reminder, I have law of sines over here. Remember, it states that the sine of an angle over the side across from it should be equal to the sine of any of the other angles over the side across from it. So here's my triangle, ABC. I've got this angle right here, 51 degrees. I've got this side 10 and this side 11. And the first thing that I'm asked to find is the measure of this angle over here, B. Now, since I don't know this angle up here, I can't just subtract from the total 180 in a triangle. So I'm going to need to use the law of sines to help me out since this is not a right triangle. So I know that I have a given relationship. I have both the angle and the side right here for C. So I'm going to say sine of 51 degrees over 11 is a relationship I have. And if I want to find this angle B right here, then I can use the side across from it 10 and say whatever sine of B is divided by 10 will be the same as this ratio right here. Okay, and now I'm going to solve for B. So let me multiply times 10 on both sides. So I have 10 times sine of 51 degrees divided by 11 equals sine of B. And I can go ahead and solve for 10 times sine of 51 divided by 11 and see what I get on that left side. Hold on while I grab my calculator. Okay, just make sure you're in degrees. And I'm going to say 10 times sine of 51 divided by 11. And I get 0.7065. Okay. And now I want to solve for my angle B inside of sine. So remember, anytime that I'm switching like my input and my output, or I'm solving for my angle, I can use inverse trig functions. So I'm going to take the inverse sine of 0.7065, and that will give me my B. So let's go ahead and do that. Inverse sine of that value I just got, and I get 44.9506. So I would take B equal to 44.950 if you're truncating, or if you round 44.951. I'll take either one of those for B. Okay? Alright, so I know this one now. I'll put it over there. Cool. Next, it asks for me to find the measure of angle A. Now, I could use law of sines if I go solve for this side right here first, but anytime I have two angles in a triangle, probably the easiest way to solve for that missing side is to just see how many degrees are left in our total of 180. So let me see what we have so far. I've got 51 plus this 44.950 gives me 95.506. And I want to subtract that from 180 to see what I have left. And I have 84.049. Okay, so I've got 84.049 degrees for the measure of angle A. Okay, and the last thing it asks for is to find the side length of A. So I could use law of sines again. I'll probably use that same one I started with, the relationship sine of 51 over 11. But now, since I'm solving for side A is going to be on the bottom, so I need sine of angle A, which I just said was 84.049 degrees. Okay, so to solve this, there's a couple things you could do. You could do cross multiplication. You could find the reciprocal of both of them and solve. You can multiply times A over to this side, and you'd have A times sine of 51 degrees over 11 equals sine of 84.049. And then if I want to get just to A and cancel both of these, I could multiply times the reciprocal, 11 over sine of 51 on both sides so that these would cancel and we'd just be left with A equals what this is equal to. So let me go ahead in my calculator and calculate that. Last step. Sine of that angle I just got times 11 divided by sine of 51. And that gives me 14.078 as my side